Welcome to the video solution for Edexcel IAL Physics. This is Edexcel IAL October 2019 Unit 3. So let's start. Question number 1. A teacher demonstrates echolocation of her student. The teacher made a loud sound and an echo returned from a distant building as shown in the diagram. The teacher and 5 students stood a distance s from the building. Each student measured the time t between hearing the sound and hearing the echo. State one source of uncertainty in the value of t measured by these students. So you need to understand which instrument students should be using in this situation. Clearly, they are not using any digital or any sensors device, so they will be using, of course, a stopwatch. That means controlled by human. So there will be a reaction time in pressing of a stopwatch. So you can say that reaction time due to using of a stopwatch will be the source of uncertainty. The table shows the values recorded by the 5 students. So this is the table, 5 students, and these are the timing recorded by the students. The students suggested that they should include in their calculations all the values of t. The teacher suggested the value recorded by student 4 should be discarded. Student 4, which is 0.75. So explain why both of these suggestions are reasonable. Okay, so this is all about validity of data set. Validity. So remember, when there is a question about validity of data set, we look for three points. Number one, we look for the range of the data, and then uncertainty, or you can say percentage uncertainty, and then percentage difference. So we compare these three, and then we figure out whether the range is within the limit of percentage difference or percentage uncertainty within the range of percentage difference, and then on the basis of this we decide whether the given suggestion or given data is valid or not. So if you see what is happening, if you take a student's point of view and you find the range, so range will be 0.91 minus 0.75. So you say that 0.91 and 0.75, so the range will be 0.16, and this is the range of the data set if you include student 4, and 0.16 second is quite close to the reaction time. But remember, there is no standard value of reaction time. Generally, you can say the reaction time can be 0.1 second to 0.5 second, or maybe or 1 second. So there is no standard range, but the range is quite small. So we can compare, or we can say that the range of the data set is approximately same as the reaction time. So of course, including the student's 4 value will not affect our measured value. So student suggestion can be considered. Next, about the teacher suggestion, teacher is saying that student 4, which is 0.75, should be discarded or excluded. And first of all, if you exclude 0.75, then the range of the data set will of course reduce 0.91 minus 0.87, which is 0.04. So quite a small range. And small range means small percentage uncertainty. And moreover, if you include student 4 value in the data set, then the percentage difference will be large enough to consider the 0.75 should be discarded looking at the percentage difference. So percentage difference you can say the percentage difference is value 1 minus value 2 divided by sometime value 1 or sometime value 2 into 100. So if you don't have any standard value, you can choose this approach, or you can say percentage difference is equal to V1 minus V2 divided by V2 if you don't have any standard value. So you can compare the percentage differences in these regard. So what happened, you can find the percentage difference of 0.75 and 0.91. So 0.91 minus 0.75 divided by, you can do 0.91 times 100, or you can do 0.91 minus 0.75 divided by 0.75 into 100, and you will see that the percentage difference in both of the cases is greater than 10%, greater than 10%. And this is some kind of normal thing, that if percentage difference is greater than 10%, then we say that there is something wrong in our data. So there must be some anomalous result in the data set. So that's how you can check the numbers, and you can write the explanation in your wording. You can rephrase in your own wording. So let me just erase so you can read. Even you can include some other range, like I did 0.91, 0.987, or percentage difference. You can find the percentage difference of 0.75 and some other numbers, and then you will see that, of course, the percentage difference is big enough to consider 0.75 as anomalous. Calculate the mean value for t. A typical question for unit 3, they give you some data set and they ask you to find the mean value, and the mean value from the data set is sum of the given data set divided by number of readings. So here, because in previous part we say that both the suggestion are acceptable, including students value or excluding. So it's your choice whether you include 0.75 or you exclude 0.75. So both are acceptable in calculating the mean value. So you can do 0.88 plus 0.88 plus 0.91 plus 0.87. I'm excluding, so I should divide with 4, and the mean value will be 0.885. So 0.885 second, and you round it off, so 0.89 second. This is your mean value. Calculate the percentage uncertainty in time t. Indeed, you for percentage uncertainty from the data set, so you find the range, and the range will be equal to 0.91 minus 0.87, which is 0.04. So this range will give you 0.04, and uncertainty delta t will be equal to range divided by 2, so 0.02 second. So percentage uncertainty is 0.02 divided by mean value 0.89 times 100. So your answer will be 2.25%, or you round it off to one significant figure, so it will be 2%. So this is your percentage uncertainty. The speed of sound in air is 330 meter per second. Calculate the maximum value of S from the student's value. So you need to find maximum value. So of course we are going to use the maximum time calculated by the student, which is t is equal to 0.91 second, and but make sure that this is the situation of pulse and echo. This is the most common mistake in these types of question, pulse and echo. So pulse and echo, where you have some barrier and you send some sound wave or sound pulse, hit and then return. So the total distance traveled by the sound wave is 2s, double s. So formula is twice of the distance, 2s is equal to u into t. U is the speed, t is the time. So s is equal to ut divided by t. So u is 330 into 0.91 time taken and divided by 2. So s will be equal to 150.15 meter. So 150.2 meter. This is the maximum distance. A student launched a small solid plastic sphere from one end of a long table to the other end using the apparatus shown. Okay, this is the launcher set by some angle. Sphere is coming, so definitely this is a case of projectile, so it will fall something like that. This is the distance traveled. The student measured the horizontal distance d traveled by the sphere for different launch angle theta. D is given by the equation d is equal to v square g sine of 2 theta. So where v is the launch velocity, which is constant, so v is constant every time in every launching of the sphere. So describe an experimental method to determine the value theta at which d is maximum. Clearly, if you see, d is depending upon theta, but not theta alone, but sine of the theta, sine function. So if you plot d versus theta graph, and this is sine, so you can expect you should have a sine function, something like that. That means the distance, for as angle increases, distance is increases, but at some particular angle distance is maximum, and then when you increase distance again, this distance start decreasing again. So that's what you need to do. So you will have to measure the distance from the meter rule for various launch angle, or angle is measured from, of course, the protector, and for various distances, various angle, and then you plot graph d versus theta, and then look at the graph where you find the maximum distance, and you can find uh, the angle, the corresponding angle of this maximum distance. So that's how you can uh, write this situation. The equation predicts that when theta is 45 degree, d is a maximum. For a student's measurement, d was a maximum when theta was less than 45. In fact, this is theoretical condition that for any projectile, ideal condition, if you launch a projectile at 45 degree, then the range of the projectile or distance traveled by the projectile will be maximum. So this is some theoretical condition, but student is measuring that maximum distance is less than 45. Suggests two reasons, and there are many reasons you can write. Number one, of course, the sphere is made of plastic, so air resistance is acting. That will, of course, reduce the range, and velocity might not be constant in every launch. So these kinds of stuff you can include. And of course there will be a parallax error because you are measuring doing measurement from the meter rule and protector. So of course there will be parallax error. You can include velocity might not be constant in every launch. It might be slightly different. A student was given a thin aluminium rod of length 30 centimeter. The rod appeared to have a uniform diameter. Explain how the student could confirm that the rod had a uniform diameter by suspending it from a thread. Excuse me. Clearly, the student is hanging the rod um, or suspending from a thread. So what a student is going to do, he will suspend the rod horizontally from the center or middle point at 15 centimeters. So if you have a rod, uniform rod of 30 centimeter, clearly you know that this is uniform and the center of mass or center of gravity of this uniform rod should be at the center. So if you hang the rod at the center, so the rod should be balanced horizontally. It should not be tilted left or right. So that's how you can figure out whether the diameter is uniform or not. The student connected the rod to an electrical circuit to make a potential divider as shown. 0.2 ohm is a fixed resistor. This is an aluminum rod of 30 centimeter length. The voltmeter was connected to aluminum rod to give three different values of X. The value of X and the potential difference V were recorded. Okay, so this is the situation. Circuit diagram. Remember, length is 30 centimeter, 0.2, and this is X from this end. Fine. And then the student plotted the values on the graph. These are the value, X is the length and V is the voltage across the aluminum rod, and these are the 3 points. Determine the value of V when X is 30 centimeter. Clearly we are given 3 points. We need to find the voltage at 30 centimeter, which is 0.3 meter. This is in meter. That means 30 centimeter is 0.3 meter. So you need to find voltage at 0.3 meter, but we cannot assume the voltage here. Clearly we need to draw best fit line. When you draw the best fit line and then extend the best fit line to find the corresponding value of voltage at 0.3 meter. So that's how you do this. This is approximately the best fit line, the passing through the point and or equidistance from these two. So you can say that this is of course a best fit line and it is intersecting here. So it is 0.43 volt. So you see that the voltage at 30 centimeter is 0.43 volt. 30 centimeter. The student measured the resistance of the full length of the rod using an ohm meter. The resistance was 70 milliohm. Determine the terminal potential difference of the cell. So if you see the diagram, so full length mean the clip is attached here, and then you need to find the terminal potential difference. Clearly if you see, you have two resistances connected in series with the power supply. So basically this is a potential divider circuit, and in potential divider circuit you know that you have ratios between the voltages and the resistance. So there are many possibilities. You can say that V1 upon V2 is equal to R1 upon R2 if you compare the voltages and the resistance of individual resistance, or you can say that Vt upon V1 is equal to RT upon R1. So now if you see, you consider these two in series, of course. So terminal potential difference across these two from here till here. If you consider this is the aluminum rod of 30 centimeter till here, and then you have, so now this is a power supply. So you can, if you look at circuit in this way, so this is the rod and we need to find terminal potential difference, this Vt. So clearly we can compare the terminal potential difference Vt of these two with the voltage of this rod at 30 centimeter, because we have the value we found from the graph. So we see that ratio between Vt over RT, the total resistance, is equal to V1 over R1, where V1 and R1 I am considering resistance of the aluminum rod. So this is my resistance 1, which is given here for 30 centimeter. So Vt will be equal to RT into V1 divided by R1, meaning you have RT is the total resistance, which is 70 milliohm plus 0.2. So it is 0.07 plus 0.27, of course. So RT is 0.27 times V1, and V1 is the voltage across the aluminum rod of 30 centimeter, which is 0.43 that we found, divided by R1 is the resistance of the rod at 30 centimeter, which is 70 milliohms, 0.07. So now we have a terminal voltage Vt. So Vt would be equal to 1.658 volt, or you round it off. So Vt is 1.7 volt. This is the terminal potential difference. The student measures only 3 values of V and X. Explain why taking further reading could improve the accuracy of his value for the terminal potential difference of the cell. Indeed, if you take more reading, definitely your graph will consist more points. You can have a better idea about best fit line. You can exclude any anomalous result. So you can, improve your accuracy. So these points you can include in this answer. Question number 4. As polarized light passes through a sucrose solution, the plane of polarization is rotated. The angle of rotation can be measured using the polarimeter shown. So this is the whole polarimeter. Rotating polarized filter, glass tube, sucrose solution is inside, light source, fixed polarized filter. Okay, the angle of rotation depends on the concentration of the sucrose solution. So angle of rotation, so this is, you will rotate the filter, so you have angle of rotation here, is equal to K times of concentration times of depth, where K is constant. A student used the polarimeter to investigate this relationship. She recorded her results in the table below. Okay, so this is the table. Concentration and angle of rotation. The depth of sucrose solution in the glass tube was 10 centimeter each time. Determine whether these results support the statement that K is constant. Clearly, if you see the relation given by which is investigated by these students, angle of rotation is this. Now, how do you see, or how can we say that the results support the statement K is a constant? So if you see, if you make K as a subject, so you see that K would be equal to angle of rotation divided by concentration of solution, and then into D, which is depth, and depth is constant. So meaning if you find only the ratio of angle of rotation, let's call it theta, maybe theta, and this is concentration, let's call it C. So if you find ratio of theta 1 divided by C1, so this is theta 1 and C1, and then theta 2 and C2. So these two ratios should be same. If they are coming same, that means K is a constant. So once when you do that, so let's just suppose K1 is equal to 8 upon 125, meaning 0.064. Let's talk about the second ratio, K2. So theta is equal to 11 divided by 170, then value will be 0. Approximately 0.064. So these are approximately same. So K1 is equal to K2, and you can check some other values. So you can say indeed uh, um, the table or the observations are supported that the K is a constant value. Explain why the polarimeter light source should have a lower power. The light source should have a lower power because if we use high power, then high power lamp will produce heating effect, and due to heat, temperature of the solution will be increasing, and this high temperature will cause the solution to evaporate. So amount of solvent from the solution will decrease due to evaporation. So concentration is going to increase, or you will say it is going to change. So we should use low power, not the high power lamp. So evaporation cause concentration to increase, because evaporation only solvent will evaporate, leaving salt behind. So concentration is going to increase or change. Describe graphical method the student could have used to determine the K. Clearly, I told you that the K depends on angle of rotation as per the formula. You see angle of rotation is equal to K into this. So if you rearrange for K, so K into D is equal to angle of rotation divided by concentration, C. So we should have a graph of theta versus concentration. We can expect a straight line, and from that straight line, if you find the gradient, so gradient will be equal to theta upon C. So as per condition, K into D should be the gradient, and K is gradient divided by D. That's how you can use graphical method to figure out value of K. The photoelectric effect occurs when photons of sufficient energy are absorbed by electrons, which are then emitted from the surface of the metal. The photograph shows apparatus used to determine the Planck constant using photoelectric effect. So this is some apparatus. This is the metal surface, potential difference controller, connection to the ammeter, filter, okay, voltmeter. Fine. The metal surface in this apparatus can be used to determine the Planck constant with visible light. Other metals require higher photon energies. Explain an advantage of using this apparatus. Clearly, this apparatus can help us to find H using visible light. If we use some other apparatus that need high photon energy, that means we need some light with high energy, like ultraviolet. And if we use ultraviolet light, so using of ultraviolet, you know that there is a risk of using ultraviolet. It can cause some damage to the environment, or you can say surrounding, or maybe our skin. So that's the one of the most advantage of this instrument, that the visible light has low energy. Some other apparatus required high energy like UV, so there is a risk factor involved using that apparatus. The potential difference applied to the circuit does work on electrons emitted from the metal surface. Calculate the work done on an emitted electron by a potential difference of 1.58 volt. So you need to find work done, and voltage is given, work done on electron. So this is basically definition of potential difference. If you recall, the potential difference is defined as potential difference is work done per unit charge. So this is a general definition of voltage. But in case of electron, voltage will be work done per unit electron or per electron. So the work done will be equal to VE. And basically this work done is nothing but energy. energy provided to the electron. So work done is equal to VE. You just multiply voltage with the charge of electron, so you can find the energy given to the electron or work done on the electron. So voltage is 1.58 into electron. This E means charge of electron. So 1.6 into 10 to the power minus 19 coulomb. And when you multiply these, so you have answer of work done is equal to 2.53 into 10 to the power minus 19 joule. A teacher used different filters to vary the wavelength lambda of light hitting the metal surface. For each value of lambda, he slowly increased the potential difference V until the reading on the ammeter fell to 0. He repeated this for each value of lambda and calculated mean value of V. The table shows his results. So this is lambda in nanometer. Nano means 10 to the power minus 9. Remember, this is nano, 10 to the power minus 9. And mean value of this, plot a graph of V on the y-axis against 1 upon lambda on the x-axis on the grid provided. Use blank column of the table for your processed data. Processed data means because we need to plot graph of V against 1 upon lambda. In the table, we have lambda and V, but we don't have 1 upon lambda. That's why they give you the middle column to calculate 1 upon lambda. So in this middle column, we are going to write the values of 1 upon lambda. And when you do 1 upon lambda, make sure that you don't just write 1 upon 380 because there is nano. So you should divide 1 divided by 380 into 10 to the power minus 9. 1 divided by 440 into 10 to the power minus 9. And then when you do that, you have the values that you can write here. And then when you divide 1 upon 380, so your value will be equal to these. Clearly, basically your calculator will be giving you answer, I guess, because we have a different types of calculator. I am hoping that your calculator will give you 2.63 into 10 to the power 6. And this 6 is basically, I am writing here as million or mega. You can write 10 to the power 6. It's your choice because I use prefixes a lot. So whenever it is given, so that's why I'm using million. So all values are given in million per meter. So 2.63 10 to the power 6, 2.27 10 to the power 6, and so on. Now we need to plot the graph of V on the y and 1 upon lambda on the x-axis. So let's move on to the grid. This is the grid, and this is our data. And now you can see you will have to choose the proper label axes, and then you need to plot the point, corresponding point, and the best fit line. So this is your axis, 1 upon lambda million per meter on x-axis. So starting from 1.3 and 1.5 till 2.7, because our range is 1.6 to 2.63, and the voltage is starting point 2 to 1.6. So when you plot the corresponding points for each corresponding reading, 1, 2, 3, and so on. So we have these points. Clearly, these points are approximately in line, and then we need to plot line of best fit. So this is the line of best fit, which is, passing from maximum point and equidistance from either side. So this is, you can choose slightly different, but it is, in my opinion, it is a best fit line, and that's how you complete your task. Next, determine the Planck constant using your graph and the equation. So this is the graph that we plotted, and we need to use the graph to find the h. So remember, h is found using gradient into E, electron charge, divided by c, speed of light or velocity of light. So gradient, of course, we need to choose 2 points on the line. So you can choose these 2 points or some other points on the graph. It's your choice. And the coordinate of these 2 points, you can see 2.6, 1.6, and 1.5, 0.2. So calculate the gradient now. So if you calculate the gradient, gradient would be equal to y2 minus y1, 1.6 minus 0.22 divided by x2 minus x1, 2.6 minus 1.5. When you solve this, a gradient would be equal to 1.25 into 10 to the power minus 6. Unit will be volt and per meter. But remember, yeah, million. Don't forget to write 10 to the power 6 here, because this is value of x in million. So 1.25 10 to the power minus 6, and the unit of gradient will be voltmeter. So this is the gradient, and now use the gradient substitute here. So h would be equal to 1.25, or you can say 1.3 into 10 to the power minus 6 into e 1.6 10 to the power minus 19 divided by speed of light, or velocity of light, 3 into 10 to the power 8. So h would be equal to 6.93 6.9 10 to the power minus 34 joule second. This is the value of h. Okay. Suggest two modifications that would improve the accuracy of the value of the Planck constant determined from this experiment. So you need to improve the accuracy of the Planck constant clearly. First of all, this is all about this experiment is all about the light falling upon the metal. So the experiment should be done in a dark room, so that every other light is cut off or should not affect our experiment. You can use a various wavelength, number of different wavelength to improve your reading. You can limit, or you can make use filter to use very fine value of the lambda. So that's how you can improve your reading. Thank you very much. I hope you understood this paper. And at the end, I'm sorry about you will feel that a lot of distortion in this video, because my computer is not working correctly. There is some problem in mic, so I'm really sorry about that. Thank you very much. Have a nice day.